Hi everyone, welcome to our fourth seminar. So this is what we will do today. So I will give you a brief review of assignment 4 and talk more about and we will focus on the meaning of regression and also the assumptions of ordinary least squares. And next, we will talk more about some tactics that you can use when you run a regression and also some operation in R. So I haven't finished the grading of assignment 3 yet, but I will try to finish the grading before Friday. For the assignment 4, I will try to finish the grading before next Monday. So don't worry. So we talked about the OLS in the last seminar, but I think you might wonder what's the so why we do the OLS and what is it about. So basically, we do the OLS, or you can think like we do the regression. The purpose is that we want to know the effects of one variable on another variable. So we want to know the effects of an independent variable on another, like on the dependent variable. And OLS or OLS regression is one of the ways to quantify the causal effects of an independent variable on the dependent variable. So in the slide, you can see the example of class size and test score. So we want to know that what's the effects of changing the class size on the score of students. And to know the relationship for the population, so for example, for the students in Sweden, then we use the sample data and run the regression. In the process, so the coefficient of interest is the beta, so it's the slope coefficient of the regression. However, since we know that there are many things not only affect test score, but as well as affect class size. And since we only list out one independent variable, so here is class size in the regression. So the other things are now in the error term, so it's here, since we didn't list out them explicitly. So naturally, since those variables are in the error term, the beta that we run can be only interpreted as correlation, but not causation. So in order to interpret beta as a causal effect of changing class size on test score, there are only two ways. So either we try to control for any other thing that affects test score and class size, or we should try to find an exogenous variation in class size. So this is what we mean by regression, and what does the regression mean, and also what's the purpose of the regression. So continuing our example. So what is a control variable? So in order to interpret beta as causal, we need to control any other thing that affects class size and test score at the same time. And those variables which can affect class size and test score at the same time, we call it an if we put it in the regression, then we call it control variable. So which means that when we put them in the regression, we can hold the variation of that variable as constant. And therefore, we can isolate the effects of class size on test score. So you can see here. So first, in the single variable regression without any control variables, so when you just run this variable, so this beta can only interpret it as correlation. Since we didn't control for anything that's both related to test score and also class size. However, when we introduce more and more control variables, then we have more confidence that the bias of the beta that we estimate is lower. So for example, here we include the parental background. So now we estimate the effects of class size on test score holding parental background constant. So in this process, as we include more and more control variables, then we can make our estimation of the true relationship between test score and class size more accurate and more precise. So this is what the control variable means. So in the assignment 4, so question 1 is to formally derive the intercept and slope of OLS. So basically, you just need to solve the least square problem by minimizing the sum of the difference between the actual and also the predicted values. So we use the calculus to solve it. And after you finish the calculation, you will get that the intercept is the average of the dependent variable minus the slope times the average of an independent variable. So now we are talking about only the case of one single variable. And for the slope of the coefficient of slope, so it will turns out that it actually equal the covariance of y and x divided by the variance of x, which is the independent variable. So this is question 1. And question 2, so which I think is the most important question. So what is the assumption of OLS for interpreting beta as causal relationship? So actually this is also the central focus of your term paper, because the purpose for us of doing the OLS is try to quantify and also try to find the accurate relationship between two variables. And the purpose for you to add like other variables in the regression is just to reduce the bias of running the regression. So first, the main OLS assumption for interpreting beta is that it should be either conditional mean zero. So first is that the other factors contained in error term should be unrelated. So for example, if we use the so if we still use test score and class size as an example, it's quite natural that this regression does not fit into the condition of conditional mean zero. Because, for example, parental backgrounds are both related to class size and also the test score. So conditional mean zero is not possible to hold. Therefore, the estimate of beta, which describe the relationship between class size and test score, it must be biased. So this is the main OLS assumption for interpreting beta as causal. And then, so this is the most important assumption in OLS. And then the assumption 2 is that the model is linear in the parameters. So there should be not, for example, square term or something like that. And assumption 3 is that the sample should be random. And there are also other assumptions for the ordinary least squares, as if you want to interpret the coefficient that you get as causal. So the first one is that large outliers are not that likely, since we can see that in essence, the OLS, the value of beta, is kind of an average. So if you have the large outliers, the estimate of beta will be easily affected by the extreme values. And the next is that the next one is about the error variance. So this one is I will talk about it in the I will talk about this in our next seminar, I think. And the next one is errors are normally distributed. So this is important for inference. And the next one is that there should be some variation in sample values of X. So for example, if in our samples, like every class has the same size, actually we cannot really know that the relationship between class size and test scores, because all the class sizes are the same. And the next one is there should be no perfect multicollinearity. So we will talk about this later in today's seminar. So this is some commonly listed assumptions about OLS. But out of them, the most important assumption of OLS is this one. So the other factors, the things in the error term, should be unrelated to our main variables, so our main independent variable. And the next question is that we need to calculate the estimates for intercept and slope in R. So basically, we just directly apply the formula that we get in the question 1. So in R, we apply log wage, so the whole log wage as Y and experience as X, and then you just simply apply the formula, and then you will get the estimates. So this is not that tricky. And then to calculate the value by R, not by manually using a formula, is that we directly use LM command, so which I also mentioned it in the last seminar. So when you when you execute the LM command, you can see that the estimate is basically the same. So it's like so our intercept is 4.215, and the beta is 0.006. So which is similar, which should be similar or the same with what we calculate by hand. And then here comes another important thing that you should remember when you write a term paper. So as I already mentioned in our last seminars, so running regression in R itself is not that tricky, or you can say that it's extremely easy. So you just type lm and then you put all the variables that you want in the parentheses, then it's done. So the most important thing is that how to interpret the value of coefficient estimate. So what does it mean? So this is also what Mahmoud stressed in the grading of your term paper. So after you run the regressions, you should be able to interpret the thing that you run. So for example, in our question 2, so now you run a log linear model, so log wage and also experience. So what does it mean here? So what does it mean by beta, for example, is the 0.006. So since here's a log, so naturally the beta should have a percentage interpretation. So when the value is 0.0066, so which means that when you have an additional year of work experience, your wage should increase by 0.66%. So it is related with an increase of 0.66% in wages. So we use associated or related, but not, but we didn't use cost or lead to, since just as we mentioned several minutes ago, since this is a single variable model, so it's quite natural that the beta that we get is not causal relationship. So it should be heavily biased, because you can easily think that there are already lots of things both related to wage and also experience. So for example, schooling or gender. So you should not interpret this value as causal. And then if you want to give even more like clear pictures of this 0.60% increase in wages to your readers. So you can see that, for example, considering an individual with the average level of wages, so the average wages is, for example, 80.25 crowns, then you can say that actually it means that if you have an additional year of work experience, then your wage will increase by 0.53 Swedish crowns by hour. So this is how you try to explain the meaning of coefficients to your readers, and also how you try to interpret the results of your regression. And then here comes our next question. So why do we take the logarithm of a dependent variable? So just as we said, so when you run the regression, basically the distribution of the variables should be normal. So since we know that the distribution of wage is typically quite skewed, so one reason is that there can be only positive wage. So there should be no negative wage. And then another thing is that the distribution of wage itself is really skewed. So compared to the normal distribution, there are still more people have really high wage, and also more people who have low wage. But the distribution of low wage is much closer to the normal distribution. So by putting log on the wage, then we can make the distribution of residuals close to normal. And then it makes us easier to interpret the value that we get as causal. So yeah, so instead of let the central limit theorem or the law of large numbers come in when it's becomes a really big number, actually we can directly use log to solve the problem. And then another thing is that the semi-log model assumes that there should be a linear relationship between log wage and the experience. So by taking the log, it will help us to have a better interpretation of the coefficient. Yes. So this is why we use log sometimes, and especially when we try to deal with the statistics of wage. So I think I mentioned this before in the last seminar. So what's the meaning when you put logarithm in the different positions in the regression? So you can take a look. And so I think I also mentioned how to draw a scatter plot in the last seminar, so I will skip it as well. And then now we talk about the hypothesis testing. So basically the idea of hypothesis testing is the same, no matter it is about the wage, no, not the wage. So no matter it is about the values of average compared to one fixed value. So for example, whether the schooling years of male is, whether the average of the schooling years of male is equal to 12 years, or it is about the comparison between two groups' average value. So for example, whether there is any difference between the average values of the schooling years between males and females. So the ideas of hypothesis testing of beta is the same with these two types, which we mentioned 2 weeks before. So to do the hypothesis testing, so it is the same. So we still use the t-test, or you can say that we use the t-statistics to test it. So the t-statistics is that we use the actual minus the hypothetical divided by the standard errors, right? So we want to see that whether the value of beta is statistically significantly different from 0. So in this case, the hypothetical value is 0, and the actual value that we get by calculation is then the 0.0066. And then now we need to calculate the standard error. So you can see that we use the following formula to calculate the standard error. So this is how we do it by R. So you can take a look. So it's just the calculation. And then now we calculate the t-statistics. So we get that the t-statistics is 13.2, so which is much larger than a critical t-value of 1.96, which stands for the 5% level. And then we can reject the null hypothesis at 5% level. Or you can directly compute the p-value to get the exact level of significance by putting the t-statistics that you get into the normal distribution function. So this is about hypothesis testing. And then the next question is about R squared and adjusted R squared. So how much of the total variance in the data can we explain with our model? So basically the R squared is that you use the explained part divided by the total part. So some students ask me that how to calculate R squared when you have like multiple independent variables. But the point is that you can see that from the formula of counting the R square. So there is, it only concerns a single variable, which is the dependent variable. So actually it is not related to the value or the number of independent variables that you put in a regression. So it only considers the left-hand side of the regression, which is y. It has no relationship with any independent variables when you calculate R squares. So basically, the way for you to calculate R squares is always the same, no matter you put only one single variable in your regression or multiple independent variables. So, so this is about some misunderstandings when you calculate R square. And to adjust it, to adjust for the natural bias of the increase of R square when you just put more and more variables. So we need to calculate the adjusted R squares. So you need to put this coefficient to adjust R squares. So the R squares is, so the adjusted R squares is to correct the bias resulting from putting more and more variables. So basically it's, the way of calculating it is similar. Yeah, so the next question is, so how much should we care about R squares? So I think this is also quite important when you try to apply R square and also adjusted R squares when you write your term paper. So honestly speaking, R square is not that important in the term paper. The reason is that, so we mentioned R squares is just for you to know, is to just give you some concepts about the regression, but actually R square is not that important in the term paper because actually there are two different purposes when you use the regression. So the one, as we just mentioned, is that we want to know the causal relationship between two variables. But another purpose of running a regression is to have a prediction. So either it is causation or it is the prediction. So what's the difference between this? So for example, we want to know the relationship between the test score and class size. So honestly speaking, the R square is not important in this. The R square is not important in these questions, since actually what we want to know is how much or whether there is, or whether class size calls low score or high score. So it's not important that the variable of class size itself, like how much that it can predict the class size, right? So, and you can think that, but now, for example, the question turns out that actually I'm not interested in the relationship, the causal relationship or the relationship between class size and score. What I'm considering is that I just want to have a model that can predict the, like I want to predict like how the scores will evolve next time. I want to predict it. So what's the next? So when next time there is another test, then how much or how many will the points be? So if the question is like this, so now the causation itself is not important. So I just want to make the fit of our model as good as possible. So if the purpose of your regression is try to predict the result of y, but not trying to study an causal effect or an effect of x on y. So in this case, then the R squared is important because R squared is how much the variation that can be explained by all the variables that you put in a regression, but not the causal relationship. So actually R squared is not that important in this class because after all, in this course, our focus is to studying the causal effect of x on y. So that's why we stress the assumption of OLS that much. So the conditional mean zero or conditional mean independence that much. So basically, R squared is not that important when you wrote your term paper or when you try to learn the causal relationship between two variables. And if you still have some questions, feel free to ask me by email, or you can read the textbook, Stock and Watson, page 276 and 277. So yeah, so next, this is how we calculate the R squared and also adjusted R squares by using R. So you can take a look. So one thing need to mention is that when you try to extract the value of regression, so when you try to extract, for example, the coefficient of slope or the intercept from the regression, you can use the command called coefficient. Yeah, so now we finish the review of assignment 4 and something that you should remember or keep in mind when you write your term paper. So now we enter a new session. So what does the dummy variable mean when you run a regression? So honestly speaking, we already met several dummy variables before. So for example, public and female in the LNU91 dataset. So a dummy variable is a regressor taking the value either 0 or 1. So basically, 0 means no or 0, and 1 means, oh, so 0 means false or no, and 1 means true or yes. So for example, if unemployed equals 1, so it means unemployed. And if unemployed equals 0, then unemployed means employed. So which means that you have a job because you are not unemployed. So including a dummy variable in a regression allows for different intercepts for male and female. So for example, if we run a single variable regression, and we include only one dummy variable as an independent variable. So actually we are comparing the means, or you can say we are comparing the variable intercepts. And in this case, beta is no longer a slope because actually a dummy variable takes the value either 0 or 1. So actually there's no slope because there are only two values in beta, right? So in the following regression, so y equals alpha plus beta times dummy plus epsilon I. So for dummy equals 1, then the value of y is alpha plus beta plus epsilon I, which is stands for error terms. And for dummy 0, the value of y actually only equals alpha plus error terms. So if this is the case, then actually we are comparing the means, right? So for example, you can think that y as wages and dummy as male. So when dummy equals 1, which means that the sample is male, then the y now is it means the average wages of male. And for dummy equals 0, then the value of y in this case is then the wage of females. So if you run the single variable regression, which only includes one time variable as an independent variable, actually you are comparing the means of two different groups. So how we create a dummy variables in R? So now we use the data sets from XDOT called crime as an example. So in the crime data set, there are 3 categories in the crime data set. So it's central part, west part, and other parts. So how can we create 3 dummy variables based on the categorical variables? So I think when you use the data set, the data set, so I think you might need to transform some categorical variables into the dummy variables when you write your term papers. So how we do is that, so first, when we want to create a dummy variable called other, so if other equals 1, then it means other area. And if other means 0, so it means that it's either central or west. So how are we going to do it? So we create an object called other, and we use and we type. So first, it is the parenthesis with region. So this variable is called region. So region double equals parenthesis other, then times 1. So just as we say that the value of dummy variables takes either 1 or 0. So that's why we use the multiplication notation to create the value is 1 or 0. So this means that, so if the region equals other and then times 1, so then it will, so for example, the first observation is from the region other, then it means that the region equals other, and then you times 1, then the value will become 1. So it means that true, and the first observation is from the region other. But for example, if another observation is from the central area, but not from the region other, and then when R takes a look, and then it will give this sample as value 0, and then when you times 1, then it will have the value 0, because 0 times 1 is still 0. So this is how it works, and why we need to type like multiply by 1. And when you create a dummy variable like of west and central, so it is based on the same idea. So you first type like regions double equals west. So since the west is in characters, so you need to put a double quotation mark and not tell R that these are strings, and then type multiplication by 1. So this is how we create the dummy variables from the categorical variables. So of course, you can also create dummy variables conditional on several conditions, not only from 1, for example, regions equals others. So for example, I want to create a variable called central 8687. So if central point 8687 is equal to 1, it means the region is from central area and the year is equal to 1986 or 1989. And if equals 0, then it means otherwise. So now we use two free arguments together and then type them. So the multiplication of 1 is the same, but we need to use AND to connect two different conditions. So this notation means AND. And this notation, the straight line, the vertical line means OR. Since now we want the value text 1 if it is from central region and the year is equal to 1986 or 1987. So what means that the target that we want is 1987 central and 1986 central. So first is central, and then when we put AND, so we need to put another parenthesis again, since we want both 1986 and 1987 in our argument. So if you don't have this parenthesis, then the R square will become confused, because in the sample there should be, because in a data set there should be no so in a data set one sample should not have 2 years. So one observation should only have 1 year, so you cannot find a single observation with 2 different years. So when we create these dummy variables, you need to put an additional parenthesis around the years. So this is something that you need to keep in mind when you create dummy variables from like different conditions or like from the categorical variables. So for example, now we run the regression of crime rates on police population density and also from the 3 dummy variables that we just created. So upper, west, and central. And you can see that there is one line of dummy variables which does not have any values, so which shows non-available. So why does it happen? So why does R shows that the value of central is non-available? So this is related to what we said about the multicollinearity. So back to our discussion of the definition of dummy variables and what it means when we run a regression. So here you can see that the value of beta is the difference between the observations when it have dummy value 1 and 0, right? So beta itself actually means the difference between two groups. And you can see that the value of intercept is actually the value of the comparison group. So if we go back to this example, so it means that actually the reference group or the comparison group in this regression is central. So actually the value of the value of crime rates of central area is here, is in the intercept. And the value of other and the value of west means that what's the difference of the crime rate between other areas and central areas, and also what's the crime rate of west, what's the difference of the crime rate between the west area and also the central area. So when we run this regression, you can see that so the crime rate of central area is 0.014, and the crime rate of other area is that you use 0.014 plus 0.007, so we get 0.021, and the value of the value of crime rates in the west area is that you use 0.014 plus negative 0.006, so we get the value of the crime rates in the central area should be 0.008. So multicollinearity means that when you run a regression, you cannot put all the dummy variables you get into a regression because you need to put one of them as a reference group in the intercept. Otherwise, there might be some error, or the R will automatically pick one for you. However, if the reference group that the R chose is not the one that you want, then you should include only n-1 of these dummies. Yes. So yeah, so this is about the dummy variables. And there's another tip. When you try to use the categorical variables as dummy variables, so you can use the factor function when you run the regression. So factor function is for a categorical variable in a regression. That is the same thing as adding a dummy variables for each category. Yes. So this is about creating the variables from the categorical variables. And of course, you can also create dummy variables from the continuous variables for example, experience. So you can specify different conditions for dummy variables of experience. So for example, I want to create 3 dummy variables for experience as well. So which is short, medium, and long. And I use the borderline of 11 and 20 for these 3 dummy variables. Then I can create, for example, a dummy variable called short when the experience is less than 11 years. So actually it is the same when you try to create the dummy variables from categorical variables. So the same, you can also use factor in a continuous variable. So you create the variable called experience level, and then you use cut to cut the borderline of experience. Then you use the factor again to do it. So this is what the experience level looks like in your data. So you can see that here has like short and medium, like 2, 1, 2, 2. So it stands for like short, medium, and long. And you can see that it's the same when you use the factor, or when you put directly medium and long in the regression. They are the same. And when you put medium and long in the regression, it means that it already implies that the reference group that you use is short. So the value of beta 3 means that the difference of log wage, between medium experience and short experience. And beta 4 means the difference of log wage between long experience and short experience. So now we talk about our last things in today's seminar. So it is about F-test. So we talk about so what we mentioned in our last seminars or before is about a single hypothesis testing. So we take a look at either beta, for example, in a regression like beta equals 1 or beta is not equals to 1. Or like the average, the difference, whether the average of two groups are the same or different. However, the F-test is the test of joint hypothesis. So let me use the following regression as an illustration. So for example, when you run the regression of wage with experienced female and public, and now we see that the experience here and the t-value here shows that 11.98. So, and which have the p-value extremely small, near 0. So it means that the significant level. So we can reject the hypothesis that the experience is 0 in this regression. So the experience is significantly affected the log wage, but this is only about the hypothesis. This is only about like one variable. So this is only concerns experience, but not other variables together. But here you can see that the F statistics here is 149.1. So this means that whether experienced female and public are jointly statistically significant, different from 0. So, so now the null hypothesis just changed. So when you take a look at the p-value here, so it only concerns whether the beta of experience equals to 0 or not. However, when you take a look at the F statistics, it's takes a look directly. It takes a look at all the things that you put in a regression, whether they are jointly significantly different from 0 or not. So now the alternative, so now the null hypothesis becomes beta 1 equals beta 2 equals beta 3 equals 0. So which means that as long as one of these variables is significantly different from 0, then we can reject the null hypothesis. So this is the meaning of F-test. So in a multiple regression, we are test the hypothesis that whether all the coefficient equals to 0 or not. So why do we do the F-test? So the purpose of F-test is to see that whether our added variables have any added values. So if you put several variables that do not have any explanatory power of the of the dependent variable, then the F-test, then you will not pass the hypothesis testing of F-test, because it means that actually those variables do not have any influence on your dependent variables. So when you test the F test. So when you directly run a regression, so the F test just tests all the variables in the regression. So which means that we didn't restrict any parameters. However, you can, for example, you can only test some variables in your regression. So if we use the crime data again, then the unrestricted model for the test is that we test police, population, and west and central together. However, we can also restrict our model for the test. So we want to only test west and central. So we want to see that whether it is valuable to put west and central in our regression. Then we only test whether beta 3 equals beta 4 equals 0, or at least one of the beta 3 or beta 4 is not 0. So actually, you can restrict the range of variables for the F test. So this slide tells you how to manually calculate the F test in the restricted model. So first, you need to sorry. So you need to calculate the residual sums of squares from the restrict model. So which means that the difference between the actual and the predicted value. And you also need to calculate the residual sums of squares from the unrestricted model. So you need to calculate both. And then you divide it by the restriction that you put. So for example, we put 2 restrictions because, for example, here we put 2 restrictions because we want to see that whether it is worthwhile to put the area dummies in our regression. So we put 2 restrictions. So we kind of force to like beta becomes 0 and test whether they are significantly different from 0. So Q stands for the restrictions and K stands for the explanatory variables, which is 4 since we put 4 variables in the regression. Then we also try to extract the value of numbers of observations, and also after we do this, then we apply the way of calculating the F test. So we use the unrestricted minus the restricted divided by the restrictions, so which here is 2. And then we divide by the unrestriction divided by the observations minus explanatory minus 1. And after these calculations, we see that actually the F statistics is much larger than the threshold of 5 significance level. So which means that the regional dummies are jointly statistically significant. So which means that when you add the regional dummies, actually it improves the fit of the model a lot. And which also means that actually it is worthwhile to put the regional dummies in the regression. Of course, you can also use ANOVA function to do the same thing. So you just you just put the restricted difference and the unrestricted difference in the ANOVA comment, then you can calculate it. So you can see here. And actually they are the same. So you just put 2 different regressions together. So one is for the restricted and the other is for the unrestricted model. And then you apply the ANOVA comment. Then the R will help you to calculate the F statistics here. So this is today's seminar. And after this seminar, I will also upload some tips for you to some tips of writing the term paper. Yeah, so see you in the next seminar.